Right, finally on them then. Question 11, we're going to do logarithms. You'll notice I've added an entry after the exponential to our derivative table of derivatives. Some calculators will write ln x. It's the natural logarithm. Shift ln on the calculator, just an ln button. Some calculators write loge on the calculator, I think. They're both one and the same thing. So sometimes you'll see me writing on the same line. Sometimes I'll just write ln. Sometimes I'll write log e. It doesn't matter because they are one and the same thing, and it's in your head it's just the same thing, so you forget sometimes because you're running on automatic. So it doesn't matter, you can write either of those, perfectly acceptable. They're the same thing then. The natural logarithm then differentiates to log of x, natural logarithm differentiates to 1 over x. Now we've got properties of logarithms, which I'd like to write down as well, because we'll be using these, and I'll always put down everything we need to use, won't I? So I'm going to put down all three to start with in this problem. Very similar to our rules for indices. If you can remember the rules for indices, you can remember the rules for logs. They come for free, basically, because they're akin to logs. Indices and logs are one and the same, really. So let's have a look at them. So remember times you add with indices? Well, it's the same with logs. Times, there we go, log NAB, you add ln A plus ln B. Times, you add. Okay? Now remember that divide? Divide, ln A over B. Divide, you minus. Top, take, bottom. There we go. Divide, you minus. Top, take, bottom, just as with indices. And then we got another rule, so I better squeeze it up here. Power, ln A to the power B equals power. What happens really visually speaking is that this little chap in the air, he's on a swing and he jumps down to ground level there. So it's B ln A. Alright? Sorry to put it in so close to the table there. So you've got power, he swings down to ground level. That's the one to remember then. For the power rule, log NAB is B, that's a B, not a T. B log A, yeah? Now you'll notice there's no obstruction here. It's a simple object to a power. There's nothing in the way, and that's the rule then. You can't, if there's something in the way, you can't do that, and we'll come to examples like that. So this rule only applies when you get an object, which can be in a bracket if it wants to be, but that whole thing must be to the power, and then this can swing down unhindered. The ground level over here, and you can write B log A. One tiny last little property I want to mention, and that's the log of 1, natural log of 1. Tap it in the calculator, and you'll see that log 1 is 0. Right? Which I'm just tapped out as well with you. ln1. Let me just do it for the sake of completeness. Yeah, it's 0, so we're happy with all those rules. And so this is the baggage we've got, so to speak. There's our rules. So now I'll write down what we need as we go through, just as reminders. I might not be able to put all the derivatives down as well, but I'll put down what we need in terms of the derivative table, yeah? And then that'll leave room for the on one page for the logarithm properties. So let's do the differentiation then. Here we've got a nice little simple problem then. Everything's on ground level, looking tidy. So dy dx is 2 lots of log x. Log x differentiates to 1 over x. So it's 2 lots of 1 over x. Let's just tidy that up then. That's equal to 2 over x. There we go. Now we input the value at x equals 3 then. Divide dx, write the 2 over x of course, wherever you see an x put a little bracket and then overwrite it with the value that we want to input, which is 3. So divide dx equals 2/3. You can tap it out as a decimal if you want to, I'm not worried, but there's the answer as a fraction, yeah? Okie dokie, let's go on. Got a few of these to do.